production function analysis is very much complemented by the cost function, because it usually serves as a constraint in our production maximization problem. So we shall study the cost function here, and we are assuming that there are two inputs, for instance V1 and V2. Their respective prices should also be known, that is P1 and P2. And if we have all of these four values, we can construct the cost function, that is total cost is equal to the sum of the products of the prices and the quantities of the multiple inputs that we are using. Here we are assuming that there are two inputs. When we plot this, we usually plot it in this way, that it becomes an isocost line, where iso means same and cost means cost. So this is going to represent a certain fixed level of cost. This is why we use total cost with a bar here, that is, it is fixed. So this total cost is equal to the same formula that we had, but these combinations have this certain tendency of giving us the same value of the total cost no matter which point we use on this straight line. So these are the two intercepts. This is the intercept with V1 and this is the intercept with V2. How we have calculated them, you can see here. V1 intercept is found by considering V2 equal to 0, and similarly V2 intercept is found assuming V2 or V1 is equal to 0. So in the isocost line curve, we substituted V2 as 0, as you can see here, and then we simplified it for V1, and we found this value, which is the same as we have written here. And when we do this, that is, we put V1 is equal to 0 here, we will get V2 as the answer. This is the same value that we have found here, so this becomes the other intercept. So this is how the intercepts can be found. Because these intercepts are very useful, once we get these two intercepts, we can simply join the two intercepts, and this straight line will give us the isocost line. Now we have another way of writing this isocost line, because in this isocost line there are two variables on x and y axis, for instance V2 and V1. So we consider them both V1 and V2. What if we want to write V1 in terms of V2? Because in a function we write this dependent variable in terms of this independent variable. So we are trying to do the same, that is V1 as a function of V2. For that, simply we need to rearrange this given isocost curve function, and here we have shifted this term, that is P2 V1, here on the other side, it becomes negative, and then we have taken few further steps, that is we have written it in a mirror image form here, and now we have V1 on the left hand side. This is what we wanted, not on the right hand side. So once we did this, we have V1 and it is equal to this after the rearrangement. If we try to do the hair splitting of this form, here we can see the V2 is the other variable, the independent variable, and with it this term, that is P2 over P1 with the minus sign, is actually showing the slope, which is a negative slope, and this is a negative slope line, so this is in lines with the given diagram. And this is a term which doesn't have any of the variables, that is we don't have V1 or V2 in it. We have the parameter price and the fixed level of total cost. So the ratio of these two will give us a certain constant, which is geometrically speaking the intercept of this diagram. So you can see that total cost over P1 was the intercept of V1. So it is here the intercept of the V1 curve, so it is also verifying. This is actually the slope intercept form of a straight line, where V1 is expressed in terms of V2. So this was a brief introduction to the isocost line, which is extensively used in our production analysis, usually as a constraint and in the next video we will use it as a constraint in the output maximization problem. Thank you.